Okay, this is going to be the second part of graphing quadratic equations or functions in vertex form. Okay, in this presentation, what we're going to focus on is the vertex. We're going to see what these values h and k look like and what it does to our graphs. So I'm not going to go over this again because this is stuff that we went over in the last presentation, the differences between standard form and vertex form. So in this first set of examples, we're going to analyze the inside number. This is our x-coordinate for our vertex. Remember that our vertex is h, k. Okay, so let's go ahead and look at our first example. We have g of x equals x minus 2 squared. So to start off with, let's go ahead and talk about our direction. Since we have a positive in front, this is going to open up. My y-intercept, if we plug in 0 for x, we get 0 minus 2 squared, which is negative 2 squared, or 4. So my y-intercept is 0, 4. I'm going to go ahead and find my vertex next. The x-coordinate of my vertex, we're going to change the sign. Instead of doing minus 2, I'm going to keep it at positive 2. There is no number being added outside, so the y-coordinate is 0. Now the thing I notice about the vertex here is that not only is it a vertex, it is an x-intercept. So let's go ahead and confirm this by finding the x-intercept. So the x-intercept, I'm going to plug in 0 for y, and I want to solve using the square root property. So I'm going to take the square root of both sides. We do not need to include a plus and minus because plus 0 is the same thing as minus 0. So we get 0 equals x minus 2. I'm going to add 2 to both sides, and we get 2 equals x. So not only is this the vertex, it is the x-intercept. Okay, we also have axis of symmetry. Axis of symmetry is x equals the x-coordinate of our vertex, so it's going to be x equals 2. Alright, let's go ahead and graph what we have so far and see what we have. So we have our y-intercept of 0, 4. We have our x-intercept and our vertex of 2, 0. This is not enough to graph, so we do need a symmetric point. So from my vertex, when we go 2 to the left, we are at 4. So we want to do the same thing on the right. If we go 2 to the right, we should also be at 4. So that is my symmetric point is going to be 4, 4. Alright, so if we go ahead and graph this now, that's absolutely terrible, but hopefully you get the idea. I'm going to go ahead and draw my axis of symmetry and label. So we got x equals 2 as our axis of symmetry. Our vertex is 2, 0. And our two symmetric points are 4, 4 and 0, 4. We also want domain and range. So our domain, again, is negative infinity to infinity because it is a quadratic or a polynomial. And our range, we want our y-coordinate of our vertex, which is 0. And this goes up forever to positive infinity. Okay, let's look at another example. We have h of x equals minus x plus 3 squared. So starting with our direction, because we have a negative, this is going to be going down. Our y-intercept, if we plug in 0 for x, we get y equals minus 0 plus 3 squared. We get minus 3 squared, or minus 9. Okay, so let's see here. Our y-intercept is 0, 9. All right, next let's talk about our vertex. Again, we're going to change the sign of the inside number. So instead of plus 3, this is going to be negative 3. We have no number being added, so our y-coordinate is 0. Now the first thing that I notice is that this is also a X-intercept because our y-coordinate is 0. So let's just confirm that. I'm going to plug in 0 for y. We get minus x plus 3 squared. If we divide by negative 1, we get 0 equals x plus 3 squared. I take my square root. Again, I don't need plus and minus because it is a 0. And then we subtract 3 from both sides. And we do, in fact, get that our x-intercept is negative 3, 0. Okay, so let's see here. We also have axis of symmetry. Remember that this is a vertical line going through the vertex, so we want to keep the x-coordinate of our vertex. We get x equals negative 3. Okay, so let's go ahead and graph what we have. Okay, so our y-intercept is, all right, let's go ahead and graph what we have. I made a mistake there. That should be 0, negative 9. So our y-intercept is 0, negative 9. We're going to go down 9 on our y-axis. Our vertex is negative 3, 0. And we have our axis of symmetry is x equals negative 3. Okay, we need a symmetric point. So if we go 3 to the right of our vertex, we are at negative 9, which means that if we go 3 to the left of our vertex, we should also be at negative 9. All right, if we go ahead and graph this, that's about as good as it's going to get. We can label our points. We have 0, negative 9. This point is -6, -9. Our vertex is -3, 0. Our axis of symmetry is x equals -3. My symmetric point is -6, -9. And then now if we talk about domain and range, our domain again is -infinity to infinity. Our range this time, since this is pointing down, opening down, we have our range is -infinity to the y-coordinate of our vertex, which is 0. Okay, so that looks at the inside number, the x-coordinate of our vertex. So now let's go ahead and look at the y-coordinate of the vertex. So note on these two examples, we're going to have no number inside the square, we're just going to have the outside number. All right, for example f, we have f of x equals x squared minus 4. Okay, so our direction. This is a positive x squared, so it opens up. I'm going to find my vertex next. If we find our vertex, there's nothing inside the squared thing, so our x-coordinate is 0. Our y-coordinate, we keep the outside number, which is -4. This is also the y-intercept. So let's go ahead and confirm that. If I plug in 0 for x, I get 0 squared minus 4. My x term goes away, and I am left with y equals -4. So for this one, my vertex and my y-intercept are 0, -4. Now we definitely don't have enough in order to graph, so we're going to go ahead and find the x-intercepts for this. If we plug in 0 for y, we get 0 equals x squared minus 4. You can solve this using factoring or square root method. I'm going to go ahead and use the square root property, so I'm going to add 4 to both sides. We get x squared equals 4. And now if I take the square root, I do need to include plus and minus with my 2. So my x-intercepts are 2, 0, and -2, 0. Okay, so let's go ahead and graph what we have here. We have all of our key points. So we have our vertex is 0, -4. And my x-intercepts are 2, 0, and -2, 0. We have our axis of symmetry is going to be the x-coordinate of our vertex, so it's going to be x equals 0. So just like we saw in our last presentation, our axis of symmetry is actually the y-axis. All right, if we go ahead and graph this, I think that's about as good as it's going to get. We label. Our points, and we're done with our graph. Okay, let's look at one more example. We have g of x equals negative x squared plus 1. So for our direction, since this is a minus x squared, this opens down. Our vertex is going to be, since there's no number inside the parentheses, inside the squared thing, it's going to be 0. And we keep the number that's on the outside, the 1. This is a y-intercept, so let's just confirm that. If I plug in 0 for x, I get minus 0 squared plus 1. My x term goes away, and I am left with y equals 1. So this one, my vertex and my y-intercept are both 0, 1. Okay, let's find x-intercepts. I'm going to plug in 0 for y. We get minus x squared plus 1 is equal to 0. I'm going to solve using the square root property, so I'm going to subtract 1 from both sides. And then I want to divide by negative 1 in order to get my x squared term by itself. We get 1 equals x squared. Take the square root of both sides and remember to include plus and minus. So we get plus and minus 1. So my x-intercepts are 1, 0, and negative 1, 0. My axis of symmetry is going to be x equals the x coordinate of my vertex. So it's going to be x equals 0. All right, let's graph what we have. We have our vertex is 0, 1. Our x-intercepts are negative 1, 0 and 1, 0. We have our axis of symmetry is the y-axis. And now if we go ahead and draw this, it should look something like this. Label our points. And we're done. Okay, so if we look at our vertex and compare it back to our original equation, note that we keep the value that's on the outside. All right, so that takes care of examples where we break down our vertex. And so in the next section, we're going to combine everything together in order to graph quadratic equations that are in vertex form. So take a quick break, and I will see you soon.